Okay, welcome to the second lesson on sequences and series. The starter, I've just forgot to record, you only missed 2 minutes, was a little recurrence relation. It was un plus 1 equals 3 un minus 5 was the question, and I told people that un was equal to 2. So what they did is they figured out what the next two terms were, because this means triple the previous number and then take away 5. So triple and then take away 5, and you get those two numbers. Okay, that's that bit. Then we were looking at last lesson's work. Okay, and then here we've got this question. We picked it. It's question 10 from exercise, I want to say 3B, probably from the active teach books. And we're sort of picking apart the question and finding out what the answers are. So it says the fifth term, that means when n is 5, of an arithmetic series happens to be 33, and the 10th term, that means that n is 10, is 68. Well, we remembered from last time the general form of any number in a sequence is called the nth term, which is a plus n minus 1d. Therefore, if we think of the two separate situations there, we've got when n is 5 for the fifth term, we get this equation, a plus 4d is 33, because it told us the fifth term was 33. And the 10th term gives us a plus 9d is 68. And then if we solve those simultaneously, I'm going to write equals 33. So I'm going to write it like you did in year 10. First time you saw these, take them away from each other. 9d take 4d is 5d. And 68 to 33 is 35, which means that d is 7. And once you know that d is 7, you can substitute back in to find a. So I'm going to substitute back in that d is 7. So this will give me a plus 4 times 7 is 28 is 33. And therefore a is 28 to 33, a is 5. Okay. So looking at this, we now know that the difference is 7. And a equals 5. Remember, a is the first term, and d is the difference. Okay, so having a look at it, let's just scroll down a bit. It then says, we have a and d. It then says the sum, the sum of the first n terms is 2,225. Well, the sum formula from yesterday is this one. The sum of a number of terms is a half n brackets 2a plus n minus 1d. That is given to you in your formula book, but it's worth remembering so you don't have to worry about it too much. So if we're given that in the formula book, or we remember it, we can just substitute in things we know. Now we know that a is 5, we know that d is 7, we also know the sum of the number of terms is what it told us above, which is 2,225. So that means that 2,225 is equal to a half n brackets. Now 2a becomes 10, because a was 5, plus n minus 1d, well, d was 7, so I'm going to write it as 7 bracket n minus 1. Close bracket. Now I'm going to expand inside. So in fact, what I'll do first, I don't like the half make things look more difficult. I'm going to times everything by 2. So this becomes 4,450. This just becomes n brackets 10 plus, then I can expand this 7n minus 7. So that was a times by 2, and this bit is the same as this. Then I would probably multiply out the n's. So I get 4,450 equals 10 minus 7 gives me plus 3. And I've got n times 7n plus 3. So that's going to give me 7n squared plus 3n. Right, let's have a look what we're trying to show. Oh, there it is. 7n squared plus 3n minus 4,450 equals 0. Well, that's actually what we've got here. So if I just write 0 equals 7n squared plus 3n, move the 4,450 across. There you go. You have now solved your question. Now, I think your calculators will solve this. And I want you to check that you can do that. So can you find the value of n, please? You should get 2 because it's quadratic. So can you find both values of n for me on the chat? My calculator won't do it. Otherwise, I've got to use the formula to complete the square. It'll take a while. So can someone do that, please?
Dad, can I have some biscuits?
And grab some out of the cupboard. Show me which ones you're getting. Right, so first person's given me 2 answers. One is 25 and the other one is minus 25.43, and 2 people have given me that. Okay, now, if we look at the question carefully, it says, hence find the value of n. Think what n is and tell me which is the value of n on the chat.
Can I have 6 of them?
Absolutely not. How many would you really like?
10.
No, that's bigger than 6. Right, you may have 2 to start with. 3's not a bad shout. You have 2 to start with. There you go. What do you say?
Thank you.
Good boy. Okay, so none of you have replied to me what you think the actual answer is. Well, n stands for the number of terms. So n has to be an integer for starters, and it can't be negative. Okay, so it has to be an integer because you can't have a -1 term, -2 term. How many terms there are in a sequence? There are either no terms in a sequence, or there are more than none. So it had to be a positive integer, therefore the answer was n is 25. Okay, so n represents the number of terms in a sequence, the 5th term or the 6th term, for example. Okay, so let's crack back onto the book and show your answer. There you go. And let's have a look at the next section of work. Well, it goes into geometric series straight after that. It makes sense to look at that, and then you've got some time to actually practice some of the questions. Like I said in the video last time round, rather than telling you every question, if you fight through it, look at an answer, go back, check it, you'll actually learn a lot more yourselves. So we're going to move on to geometric series. We talked about it yesterday, but we didn't actually do any maths on it. I just explained to you how it was linked to the R number. Oh yeah, okay. That's nice of each other. Okay. Make sure he does get them. I'll be checking. They can't disappear on the way up the stairs. Right, so can you give me 1 to 10, sorry, on the previous question, which is this one, before I move on? Wow, 8.6. That's getting very niche. Okay. Right, okay, so let me see if I can find one similar that you could have a go at. There might be another one similar. Let's have a quick look. Okay, it's similar-ish. There's question 6. You have a go at question 6, and then I will move on to the geometric series section. Okay. Okay. Right, here we go then. I'll just take a quick picture of it. Is Eddie okay with that? That won't be charging off yet, Charlie. It's only on 4%. Careful with the cable.
Yeah, so.
Okay. Right, so this is how you do this one. The sum of the first 3 terms is 12. So, and it's arithmetic. So from these 4 pieces of information, remember the sum formula is a half n brackets 2a plus n minus 1d. And if we substitute this in the first 3 terms, okay, so the n is 3, equals 12. So I'm going to replace this with 12 is the actual answer, a half, 3 terms n is 3, 2a we don't know, n was 3, so it becomes 2d, like that. So what I will do is, I don't like the half, I'm going to times this by 2, so I'm going to get 24 equals, and then that'll be 6a plus 6d. So I get an equation involving a and d. Then it also tells me this information. If the 20th term is the nth term, which is, remember, a plus n minus 1d. So if the 20th term, so that's n is 20, is equal to minus 32, that means minus 32 equals a plus, if n is 20, that's 19d. I don't like the way that's written, so I'm going to probably, well, no, I can leave it like that, I suppose. Just don't like the way it's written. Okay, so minus 32 equals a plus 19d. It says we want to find the first term of the common difference, so we're going to solve these two simultaneously. So if I'm doing that, how would I go about doing it? I would probably replace, no, I'll just times it by 6, I suppose. Okay, I'm going to times this whole equation by 6, because if I do that, I get a 6a term. So 32 times 6, 180 plus 12 is minus 192, is 6a, 620s are 120, so that is 114, I think. 19 sixes. Okay, and then underneath that, so I've done that to make the a's the same, I'm going to bring this equation next to it. So I'm going to say that's 24 equals 6a plus 6d. Should be a d there. And then to substitute, I'm going to subtract them from each other. Minus 192 take away 24 is going to be 8, 16 minus 216 equals 6a takes 6a is nothing, and 114 takes 6 is 108d. This is not looking very good. I wonder if I've done so. Oh no, if you double it. So therefore d is minus 2. So if d is minus 2, then I can find a. I'm going to substitute d is minus 2. Oh, someone said you can divide by 6 to make it simpler. Oh, wow, that would have been so much easier. Yes, that would have been so much easier. Thank you. I just didn't. So d is minus 2. Substitute that in here. 24 equals 6a minus 12. So 36 equals 6a. So a was 6. Okay, so a was 6, d was minus 2. And thank you to the person who said I should have divided by 6. Absolutely should have done. It would have been a lot quicker. Okay, right, moving on to geometrics. Oh, before I go that, 1 to 10 on that, please. Okay, so it's about forming, it's probably about forming the equations is the issue. You're starting to get familiar probably with the formulas. This is the summing formula, that is the nth term formula. You have to get familiar with these for geometric as well. So there are new ones for geometric. You'll have to spend probably an hour, hour and a half, I would imagine, looking through the questions and the work solutions on the Active Teach, and then eventually go back to the integral site. But right now, for the new learning, stay with the Active Teach, and then I will also do some of the integral ones as well to help you through it, because it'll be in a similar sort of notation and wording and stuff, but this will give you a better, deeper understanding. So, next section is now the geometric series. and sequences. And this is where, rather than adding, we are having a multiplication or a ratio. Remember the R number? Connecting the terms. So geometric series. To remind you from yesterday, you just need a starting number and then a ratio. For example, I could start with 64, and then my ratio, so this would be our A. And rather than having a difference, so A is still the first term, R is the ratio, which is what you multiply by to get the next number. I'm going to say the ratio is going to be a half. Therefore, your sequence here would have been 64, 32, 16, 8, 4, 2, 1, half, etc. Okay, so you can see this list. That's a reminder of what a geometric series is. The notation for this, you still have A is the first term. The new one, R, stands for ratio. You still have a sum. I'll tell you about how you do the sums in a minute. And you also have a sum to infinity. And this, for example, would have a sum to infinity. If you think about adding these numbers together, starts off quite big, then it gets a little bit bigger, and only a little bit bigger, then only, so it tends to get smaller and smaller increments. Therefore, it's going to head or end up being a particular value. Right, so that's the idea behind geometric series. Let's think about what the general rule is for one of them first of all. So instead of 64, I called that particular letter. It's the first term. I called it A. Just using algebra, and someone on the chat, tell me what you think the second term would be. Kind of, but that's just, I want algebra only. I don't want any numbers. Yes, excellent. So the next term of the series here has to be general, because this ratio I chose a half, remember, but it could have been any number. I could have chosen 3, in which case the list would have got massive really quickly. So this one is AR. What is the next one is going to be AR, but it's now times another R, so it's AR squared. And the next one, you're times in by another R, so it's AR cubed. So your job is to think of the nth term. Yeah, that was the first term. That was the second term. This is the third term. This is the fourth term, etc. What would the nth term be? Have a think about that. Write it down in the chat if you think you know. Right, here we go then. So if the first term was just A, and the second term was A with a single R, the third term was A, but this time it's R squared, the fourth term was A, and this time it's cubed, you can see the difference between the term number here, the 2, and the power of R. It's always 1 less. You see, fourth term becomes AR cubed, third term becomes AR squared, second term just becomes AR. So in fact, this is AR to the power of n minus 1. That is the nth term of a geometric. It starts with A, and then you times it by a ratio to get the next one. You times it by a ratio again to get the next one. So there's your first answer. Can you give me 1 to 10 on that answer for me, please? Okay, an average of 7.5 on that one. So I'll just remind you of a few more lists so you get the concept. So I'm going to pick a number. I'm going to pick number 2. So I'm going to say A equals 2, R equals 3. I want you to tell me the first 1, 2, 3, 4, 5, 6 terms. So this is question 1. Can you just do those on your piece of paper? Number 2, I'm going to tell you that A is 100, R is a fifth. Number 3, A is 4, R is -1. So give you some time. See if you can find those numbers in that list. Okay, so for the first geometric series, you're starting with number 2 and the ratio is 3. See what answers you get. Same for 2, same for 3. Okay, I've put answers up. Have a look at the answers I wrote up in terms of generating geometric series or sequences. Can you 1 to 10 if you've got those answers? Okay. So we're now up to an 8.5 as an average of getting a sequence. And the way you do it, what I'm going to do is write underneath each one the algebra behind it. So underneath this first one, this was just A, remember, because A was 2. This was 2 times 3, so I'm writing AR, because it's 2 times the 3, that's where the 6 came from. Here, this is A. It's the same as the previous AR, which was 6. I'm timesing it by another 3, so I'm timesing it by R again. Now, if we think another way, we could square the R first. 3 squared is 9 times 2 is still 18, still works. Here, AR cubed, because it's the previous number, but I'm timesing it by R again. So if I times AR squared by R, I'm going to get AR cubed. Therefore, if I could cube the R, 3 cubes 27, double it, I still get 54, doesn't matter. And therefore, this one would have been AR to the power of 4. Noticing this is the first term, this is the second term, third, fourth, fifth, etc. So the fifth term of the geometric series is given by the expression AR to the power of 4. Same over here, this is your A, 100, we started with it, that was okay. And then the next one was 20 because we did 100 times a fifth. So we did AR for that one. This one, AR squared, because I'm taking the previous value, which we called AR, and timesing it by R again. So that's why it's AR squared. And if you do 20 times a fifth, you'll get 4. But if you do R squared, a fifth times a fifth is a 25th. And then 100 times a 25th, it's still 4, but it still works. And the same process, this becomes AR cubed, this becomes AR to the power of 4, and this is still the first term, the second term, the third, the fourth, and the fifth term. This one, this is an oscillating term. It goes up and down, up and down, up and down like this, okay? By sticking a minus in, the process of minus has it keeps changing its sign, because a minus times a minus is a plus, and then a plus times a minus is a minus. So -1, you times this, which is your A value, by -1. So 4 times -1 is -4, so that's your AR. And then times this by another -1. -4 times -1 is +4. So this is your AR squared, etc. It's always the same. Get in the habit of knowing the general form for a geometric. Can you give me a hand at a 10 for that explanation, please? Okay, perfect. I'm much happier with that. Okay, so now we've got this idea of geometric series can be created by giving a starting value and a ratio, and you list them. Sometimes they can oscillate, so why don't you just have a quick try at this one? Question number 4. If I say that A equals 2 and R equals -3, can you do the first 5 terms of that? Just do it on your paper. Okay, so this time it is the same as the first list, except you're oscillating or alternating between the minus numbers. So you get 2, -6, 18, -54, and 162. Okay, now, similar to what we did with arithmetic, they might use, they might tell you particular values of a series and then ask you to find the ratio. So, if I gave you this thing here and I said, there's a number, we don't know what it is, but then it goes 7, and then 21, and it carries on like this. If they gave you a partial part of the list, but they told you it was geometric, like that, if they told you that, how could you then go about finding the ratio? So think about it. They're telling you this series here is a geometric series. They would ask you to find the ratio. Well, to find the ratio, you do the following number divided by the previous number. So in this situation, the ratio would be 21 over 7. So the ratio would have been 3. Now, if you know the ratio is 3 and you're told it's a geometric series, you can find the other numbers. Because to get from one number to the next, here to here, this way, you're multiplying by 3 because it's getting 3 times bigger. So this one would have been 63 and this one was 189. Also, you can go this way, which would be dividing by 3 because it's smaller. This would have been 7 over 3. So if they just tell you a couple of bits of information, you can work out other numbers in a list. So leaving that on the screen for you. If I say that we have blank, blank, I don't know, 18 and 27 blank, can you think about what is the ratio? And if you know the ratio, can you see if you can find out what the other missing terms are? Think about what I've said about finding the ratio. Use that answer for the ratio to find out the following terms and the previous terms. So if someone's just entered the chat, this time I'm giving I'm telling people in advance it's a geometric series, which means it's continuing in a ratio, i.e. multiplication or division. Therefore, if you used to get 2 values that happen to be next to each other, you can work out what it is. So I've done it here. I've given the information. It is a geometric series. That's what we're talking about today. So this is also geometric. Given the values of 18 and 27, your job is to find out what is the ratio and hence what are the next and previous terms. So if I do that, the ratio is the next number divided by the previous number. So it's 27 over 18. Well, that cancels down. 9 fits into both of those. So that will go into 3 over 2, which is 1.5. So to get the next number, we have to times by 3 over 2. To get the previous number, we'd have to divide by 3 over 2. Now remember, dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by 3 over 2, times this number 18 by 2/3, which is 12. And then to get the next one, times this by 2/3, which is 8. Okay, so that's how you would do that, going backwards. To go forwards, the ratio is 3 over 2, so you're multiplying to go forwards here. So you're multiplying by 3 over 2. Well, 27 times 3 is 81. 81 over 2 is 40.5, or you could leave it as a fraction. That's how you do that. Can you give me a hand, 1 to 10 on that for me, please, guys? Okay, thank you. Right, give you another. So here we go. We're going to go for I'm going to tell you this is geometric. I want you to fill in the other values for me, please. So this is a geometric series. Can you fill in the other values? First, find the ratio. Once you know it, you can continue the pattern. Okay, so for this one, the ratio is going from 40 to 20, so it's actually getting smaller, but the formula is the same. You do the previous, and the next term divided by the previous term. So the ratio is 20 over 40, which cancels down to a half. And you can see it's a half because that is halving to get that one. Therefore, you halve it again. 20 times a half is 10, and then 10 times a half would be 5. Going back the other way, opposite of halving is doubling, so it would have been 80 and it would have been 160. Can you give me 1 to 10 on that for me, please? Okay. Now, this is all numerical. They do give you values that are non-numerical, so they will ask you to find certain things. So this time, I'm going to give you an algebraic geometric series. We're going to stop soonish because all the fiddling around with teams is awkward, and we'll continue this tomorrow, but not tomorrow, sorry, Monday. If it was algebraic, if I said that 2x plus 1 was the first term, I said that x was the middle term, and I don't know, 5x minus 8 was the third term. Okay, I just made those up. I've no idea how this is going to work at all. But if I said this is geometric, and I asked you to find the ratio, think about what we know in terms of geometric series and its ratio and terms that are next to each other. So anyone in the chat, I'll say all that again. What do we know about a geometric series and terms that are next to each other and its ratio? Yes. So someone has just said the ratio is the same. For geometric series, the ratio is the same. Okay. So on the one above in this greener bubble here, you see the ratio from 160 to 80. The ratio here was a half. 80 to 40, the ratio is still a half. Here it's still a half. So the ratio is always the same. So if that's the case, and we have a geometric series with these three terms, The way you're finding the first ratio is how you get from this one to this one. You would do x divided by 2x plus 1. That's this one divided by its previous one. Well, that ratio, call it r, must be equal to this one here, 5x minus 8, divided by x. The next one divided by the previous one. So if that's the case, you can then start to solve an equation to find the ratio. In this situation, you would times both sides by x to give you x squared, and you'd get 5x minus 8 equals 2x plus 1. You'd then multiply that out, and you'd solve it. Once you found the value of x, you could then start finding what the ratio is, because once you know x, you can substitute the x value. So here you would then find x by solving the quadratic, and then you would substitute it back in to these three things, and then you could find the ratio. Now that's taking it to one more step further, but at the moment, the idea about recapping the arithmetic and starting the concept of geometric, just so you know, I want to see where you lie on what I've just said. Can you give me 1 to 10 on what I've just said about the algebraic geometric series? Oh, good. Okay, an average of about 8.5 there. Like that. Right, sorry about the teams. I will feed that back to the head and other people at school and say, look, this is much better. Can we confirm that the sound and the screen and all the other things are better on this? Would you generally prefer this? Just say, yes, you would. So say yes, yes, yes. This is much better. I prefer Zoom. Yes, okay, so pretty much 100%. Okay, right, I'll stop the recording here. I'll see you Monday at 11 o'clock, and yeah, have a great weekend, guys.